So let's start recording. All right, let's do this. Remember that you can convert a log to exponential and an exponential function to a log because they are inverses of each other. And remember that the base of the exponential and the log cannot equal 1. And then we have a new property, which is the log equality property. So this is one new property for logs. I don't think we have any more after that. So here is, if the log base A of m is equal to the log base A of n, then if the log bases are the same on both sides, then all we have to do is set the inside of the logs equal to each other and solve for x, y, z, or whatever variable we are given. So if the log bases are the same, we set the insides equal to each other and solve and solve. There you go. This is almost like the exponential equality property. Remember, if it was a to the u equal a to the v, if the bases were the same, then u equaled v. All right. So we see that they are definitely inverses of each other with those types of properties. Okay. So let's go ahead and start solving, and we're gonna use those 3 main log properties we learned last time. Let me just write them down again so we have them. So product to sum, do it here. So if we had log or natural log of xy, this became log x plus log y. And then if we had log of x over y, you'd get log x minus log y. And then if we had log of x to the n, you would just bring that n down and get n times the log of x. So those are our 3 main properties. Yes, there's others that we could use. Okay. So let's go ahead and do this. So number 1, we have 2 log base 5 of x equal to log base 5 of 9. So in order to solve for x, we need to have the logs by themselves. So what we're going to do here is reverse power rule. This 2 is going to go back on top of the x. So remember that all these properties we learned can also be reversed. So this will become log base 5 of x squared equal to log base 5 of 9. Now I put parentheses around them. Why not? And now we can actually use the new property we learned above, because we see that the bases are the same, which means we can set the inside of the logs, the values inside of the logs, equal to each other. Okay. So when we do that, you'll end up with x squared equal to 9, square root both sides, and x equals plus or minus 3. Okay. Which one do we keep and which one do we get rid of?
We would keep the positive.
Good. We'd keep the positive. So we'd get x equals just 3. We can't use the negative because if I plugged it in and if I said log base 5 of -3, well, we cannot take the log of a negative number. So this is why we only keep the positive one. Okay. Sweet. Everybody go with that? Show me those thumbs ups. There you go. Look at that. No thumbs ups get you kicked out of the Zoom. Okay, let's keep going. Number 2, 3 log base 2 of x equal to negative log base 2 of 27. So What we're going to do here is the same as we did above. Let's go ahead and get the logs by themselves, meaning let's go ahead and move those numbers by using the power rule. So for 3 log base 2 of x, I'll take this 3, put it back on top of the x. That negative, I'll put it on top of the 27. So you'll get log base 2 of x cubed equal to log base 2 of 27 to the negative 1. Okay. And now we see that the bases are the same, which means you'll set the insides equal to each other, and you'll get x cubed equal to 27 to the negative 1. Okay. Well, to make our work a little easier, we can rewrite 27 as 1 over 27. Or sorry, 27 to the negative 1 as 1 over 27. And then we will cube root both sides. And we will end up with x equals 1/3. All right, perfect. And of course, 1/3 works because if you were to plug it into the log, it is a positive number. Okay. Everybody good with that? Oh, no thumbs up this time. A clap. All right, perfect. 1 thumbs up means everybody's good. Okay. 3, log base 5 of x plus 6 plus log base 5 of x plus 2 equal to 1. Okay, so we want to solve for x. So this means we're going to put our logs together. We're going to put these 2 logs as one single logarithm using those 3 main properties. So we see that these logs are held together by addition, which means I can rewrite them as a single log with the product of their values. So this now becomes log base 5 of x plus 6 times x plus 2 equal to 1. Okay. We still have to solve for x. So what we're going to do now is rearrange from log to exponential, which means that we're going to take 5, raise it to the first power. So you get 5 raised to the first, and we set it equal to the inside of the log, which is x plus 6 times x plus 2. All right. And now the log is gone, and all we have to do is solve for x. And we also know that 5 to the first is just 5. Okay. So we're going to get 5 equals, FOIL this out, x squared plus 8x plus 12. Move the 5 over, and 0 equals x squared plus 8x plus 7. Okay. And now let's go ahead and factor this. And the only factors of 7 that can make 8 are just 1 and 7. Set these equal to 0, and we get x equals -1 and x equals -7. But our question now is, who works and who doesn't work? And one quick way to find that out is just to check your work. Let's say we wanted to check, and we check x equals -1. You'll get log base 5 of -1 plus 6 plus log base 5 of -1 plus 2 equal to 1. Here we get log base 5 of 5 plus log base 5 of 1 equal to 1. And this is going to check out because log base 5 of 5 is 1. Log base 5 of 1 is 0. And 1 plus 0 equals 1. So x equals -1 checks out. All right, who's making me dizzy over there? Let's see. Turn. Bam, there we go. All right, thank you. All right.
So, you know what I did that got the same answer?
Did you change 1 into log base 5 of 5?
Yeah.
Yeah. All right. We'll get into that then too. I don't need to write check again. And we'll check equals -7. And you'll get log base 5 of -7 plus 6 plus log base 5 of -7 plus 2 equal to 1. And here you'll get log base 5 of -1 plus log base 5 of -5. Well, this doesn't work out because we cannot take the log of negative numbers. Okay. So this means that -7 is our extraneous solution. Okay. Now to dig in on what Carl's saying is we have another option to solve this. So what he did is after you combined logs on the left side, let's see, option 2. You start with log base 5 of x plus 6 times x plus 2. And he did a little out of the box thinking, but he used log properties. So look what we did here first. So log base 5 of 5, we said is 1. Well, what Caro did is he took 1 and wrote it as log base 5 of 5 because they're both equivalent statements. So now over here.
So I didn't even write them together like that. I left them as 2 separate logs on the left side.
Oh, you left them as, oh, and did you move everything over or what?
Well, if you leave them as 2 separate logs, you get x plus 6 plus x plus 2 equals 5.
And then you condense them all into one?
Yep.
Nice. Even better. All right. Okay. Okay. I like that. We'll dig into that too then. Because then even if you rewrote it as log base 5 of 5 with this one, you'd see that your bases are the same. And you'd end up with x plus 6 times x plus 2 equal to 5. And that's exactly what we had over here. Okay. Okay, and I guess one more option to look at, right? Why not? Since logs are definitely crazy. Let's see. So let's bounce off this one more time. Or you left it as log base 5 of x plus 6, whatever, of x plus 2 log base 5 of x plus 6 equal to log base 5 of 5. And then you moved it over?
I didn't move anything over. I just, from that point right there, just you have your log equation property. So it just becomes x plus 2 plus x plus 6 equals 5.
But we can't do that because of the plus though, right?
I mean, it worked out.
It worked out, Carl, but no. Because remember, the equality property has to just be one single log on both sides. Right?
Yeah.
So, yeah, don't do that.
Might
then
accidentally get it right.
Yeah,
because then some other time.
Yeah, because then assuming that, you would actually get x plus 2 plus x plus 6 equal to 5. And that's not what we have, right? Hey, that's a good thought, though. All right. Yes. The magic math. Okay, cool. So just that as another option. Option 2. Okay. Sweet. All right. Number 4. Same exact thing. 4 is the natural log of x equals the natural log of x plus 6 minus the natural log of x minus 4. Okay, so again, we want to solve for x. But before we do so, we want to combine these as one single logarithm. So the left side will stay the same, but now the right side, we see that they're connected by subtraction. So this means that they're going to be rewritten as a quotient. And then we know that the base of the natural log is e. So we see that these have the same bases, which means we can use that equality property. And we'll get x equals x plus 6 over x minus 4. Okay. And now the logs are gone, and all we have to do is solve for x. So this means that x minus 4 is getting multiplied to the left side. So we'll get x times x minus 4 equal to x plus 6, and solve for x. Distribute the x squared minus 4x equals x plus 6. Move everything over, and we'll get x squared minus 5x minus 6 equal to 0. Okay, and now, of course, all we have to do is factor. And of course, the factors of 6 that will get you -5 with that sign set up, because that's going to be x plus a number and x minus a number. And the factors of 6 that will work for this are going to be 1 and 6. X squared negative. Yep. And here we get x equals -1 and x equals 6. But again, do they both work? Does one work, or do none work? So you can definitely check your work again. Let's go ahead and check both. So at x equals -1, you'll get the natural log of -1 equal to the natural log of -1 plus 6 minus the natural log of -1 minus 4. Well, this is already dead giveaway because we can't take the natural log of -1. So -1 is out. Okay. And then check 6. And you'll get the natural log of 6 equals the natural log of 6 plus 6 minus the natural log of 6 minus 4. And then that would give you the natural log of 6 equal to the natural log of 12 minus the natural log of 2. And then by log properties, I guess I could have plugged it into that one. Either way, you get the natural log of 6 equals the natural log of 12 over 2, and those would check out. All right, cool. Everybody good so far? repeat with a different, I like it. All right, check mark. One check mark means everybody's good, huh? All right. Okay, 5. 3 times the log base 7 of x minus the log base 7 of 2 equal to 2 log base 7 of 4. Okay. So more log properties here that we're going to use. And what we see first is that on the left side, we can combine these two logs. They have the same base and they're connected by subtraction. So that 3 will stay on the outside and you will get 3 times the log base 7. And since they're connected by subtraction, is going to be log base 7 of x over 2. Okay. And then on the right side, we see that we can take this 2 and move it to the 4. Move it as on top of the 4. So you'll get log base 7 of 4 squared. All right. Well, we can almost use that log equality property. We just have to get rid of this 3 now. So that means that this 3 is going on top of this x over 2. And you'll get log base 7 of x over 2 cubed equal to log base 7, and 4 squared, we know that that is just 16. Okay, perfect. And now we see that the bases are the same. So you can set the inside of the logarithms equal to each other. And we'll get x over 2 cubed equal to 16. All right. And now, in order to solve for x, we, of course, are going to, what is this, cube root both sides? Oh, wait. We don't have to cube root just yet, right? We can make this a little prettier. But I guess either way, you'll get the same answer, right? What do you think, Carl? Just cube root?
I don't think you will get the answer. I think you should the same way both times. I think you should cube it first.
Cube it first?
Yeah.
So get x cubed
Let's
over
see.
8.
You do it without cubing it, and I'll do it cubing it first, and we'll see what we get.
Wait. So I'm going to cube root it?
Okay, you solve that one. I'll cube root it. We'll see what we
Okay.
get.
All right, perfect. So I cube the left side, and I move that 8 over to the right. And 16 times 8 gives me 128, right? I think so. Yeah, 128. Okay. And now we cube root both sides. And now we have to break down the cube root of 128. And you're only looking for perfect cubes. Well, lucky for us, we know that 8 and 16 made this. So that means that this can be actually 64 and 2.
Yep, it works.
So cube root of 64 gives me 4. And our final answer is x equals 4 times the cube root of 2. Is that what you got?
Yep.
Cool. Which way do you think was easier?
I think working on the cube root of 16 feels easier. probably than the cube root of 128.
That's true. So this would give you x over 2, and the cube root of 16, we know that's 8 and 2. So that would give you 2 cube root of 2. And then you'd get x equals 4 cube root of 2. Ding, ding, ding. Yep, that one's way better.
Slightly more obvious numbers.
Yeah. Either way, you get there. All right. And since 4 cube root of 2 is a positive number, then it's definitely going to work in our log. So no need to check there. All right. Any questions on that one? No. An X. No. Okay. 6. We have the natural log of x minus 3 times the square root of natural log x plus 2. All right. So what we're going to do here is factor this by U substitution. You could also solve it another way. We can move everything over to the right. Well, we can move the natural log and 2 to the right side and then square everything. But I think U substitution is going to be easier. So we're going to say that the square root of natural log x is u. And then if you square that, you'll get the natural log of x, which is u squared. So let me just write down what I said. U equals the square root of natural log x, and u squared would just be the natural log of x. Okay, which means we have u squared minus 3u plus 2 equal to 0. Okay, which makes this problem a lot easier. It looks a lot easier to work with. Okay, and this is an easy one to factor. It's minus plus, and you get u minus 1, u minus 2 equal to 0. And here u equals 1 and u equals 2. But now we made a substitution, and u is actually the square root of the natural log of x equal to 1 and the square root of the natural log of x equal to 2. So now we have to get rid of that square root. So this means we're going to square both sides. And we will get natural log x equal to 1 and natural log x equal to 4. Okay. But we have to solve for x. So we have to get rid of that natural log. And the only way to do so is to convert from log to exponential. Now, since this is a natural log, remember that the base is e. So when we convert, it's going to be e to the first power equal to the inside of the log, which is x. Same thing over here. E to the fourth equal to the inside of the log, x. And that should be good enough. Oh, man. Okay. And there we go. And e to the first and e to the fourth are both positive numbers. So they'll work in a natural log, but we're not too sure if they'll actually work in the equation. We can check. We have time. X equals E. All right, so here you'll get the natural log of E minus 3 times the natural log of E plus 2 equal to 0. Remember from our properties that the natural log of E is 1. And that means that'll give you 3 times the square root of 1 plus 2 equal to 0. So that just gives you 1 minus 3 plus 2. And yes, that checks out. That's 0. All right. What about e to the 4th? Natural log of e to the 4th minus 3 times the square root of the natural log of e to the 4th plus 2 equal to 0. Well, we can use power rule on this, and I'll get 4 natural log e minus 3 square root 4 natural log e plus 2 equal to 0. And again, remember that the natural log of e is 1. So you get 4 minus 3 times the square root of 4 plus 2 equal to 0. And this would be 4 minus 3 times 2 plus 2 equal to 0. And 4 minus 6 plus 2 equal to 0 checks out. So they're both great.
Oh my gosh, this is why you don't want to take higher mathematics. I can't even do addition normally anymore.
Oh my goodness. Carl is checked out and it's Wednesday.
No,
it's Wednesday, my dudes.
No, I did it right, but instead of just
Hump
doing
day.
4 minus 6 plus 2, I was like, oh, that's negative 6 2's. And then I've got 2 2's and then another 2. Oh, it's okay. So we got negative 3 2's. Okay, it works out. It's 3 2's minus 3 other 2's. It works. I'm just like, my fucking life as a abstract algebra is killing me.
There you go. Now you just wear a tutu. Okay.
Yeah, I wish.
Tutu.
That's what I feel like. That's what I feel like I should be doing. If I was just wearing a tutu, maybe all this would make sense.
There you go. It has to be on your head.
Mm-hmm.
All right. That is solving logarithmic equations using all the properties we have learned so far. Does anybody have any questions over these problems?
Now, can you do one that's going to be like the last 2 or 3 problems on our homework assignment that never matches up with anything over here?
Oh, well, it doesn't have to match up.
I mean, it matches up. It's just, it takes a lot of extra thinking. And I always have a hard time getting that frame of thought going.
Understood. Just remember that, yeah, like when you're working the homework, I mean, if you have your notes out with you, just know that it's the process. Like, hey, can I apply this formula to it? Can I apply that formula to it? What could I use? Because basically we're just showing you the steps and it's how you will survive. It's like, okay, he did this, he did that, and you're able to use that formula. Like, could you do the same? And if one formula doesn't work, try another one. If another formula doesn't work, try another one. Because the answer's in there. The problem may not look the same, but the process is definitely the same. So something to think about. All right, what do we have? Exponentials. Ooh la la. These are crazy. All right. I think I'll do 1, 2, 3, 4. And do you want to do the last ones, Carl?
Sure.
Don't matter. All right, I'll start these off. Okay. So here we solve exponential equations. So remember, if you're stuck in exponential form, you can always convert to logarithm. Okay. So number 1, we have 2 to the x equals 5. So in order to solve for x, we're going to convert this from exponential to logarithm. So remember that the base of the exponential becomes the base of the log. So when we convert this, this becomes log base 2 of the outside number of 5 equal to the exponent of x. Look at that. And we have x all by itself. And now this is a great answer, but if my math lab wants you to convert it to a decimal, then we're gonna have to use change of base, which means that it can be rewritten as log 5 over log 2 equal to x. And I'll just use my calculator that I have here. And log 5 over log 2, we'll get 2.322. Yeah, that's fine. Okay. All right. So there's always another way to solve these. So what we can do here, again, here's option 2. We'll start all over again. I'll say 2x equal to 5. And what I'm going to do is apply the log to both sides. So this means I'd say log of 2 to the x equals log 5. So I apply logs to both sides. And then I'm going to use power rule, which means the x will come down. And we'll get x log 2 equal to log 5. And now all we have to do to solve for x is divide by log 2. And x equals log 5 over log 2. And that's what we have right there, guys. So I know my math lab will accept both answers. It will accept the first one, log base 2 of 5, and it will even accept the second one, log 5 over log 2, because they are equivalent. Okay, but that is 2 ways to solve a log. Everybody good with that? No more thumbs up. Sad day.
I gave you one on camera. You see my one on camera.
Thanks, Carl.
You're welcome. I do my best.
wonder what TV show they're watching. Or they're probably working on their homework.
That's
All
exactly what I'm doing, to be honest.
Yeah. Thanks a lot.
Still listening.
Oh yeah. All right. Just exactly what I want to hear. But okay. All right. Number 2. 1.2 to the x equals 0.5 to the negative x. So let's go ahead and solve for x. So what we're going to do is, again, convert from exponential to logarithm. And I'll use the base on the left side. So here's our base of 1.2, and we get log base 1.2 of the outside number, and it's going to be this whole thing. 0.5 to the negative x set equal to the exponent of x. There we go. Okay, so we have just converted from exponential to log. And now we will use power rule on the left side. This negative x is coming to the front. Okay, so you'll get negative x times log base 1.2 of 0.5 equal to x. And now since we're solving for x, we want to put our x's together. So what we're going to do is add this whole thing to the right side, which means we're going to get 0 equals x plus x times log base 1.2 of 0.5. And now, once again, we are solving for x. What we're going to do next is factor out an x. And we get 1 plus log base 1.2 of 0.5. And now in order to solve for x, we are going to divide by all of that. And would you believe it or not, we did all of this work just to get an answer of 0. Good times. Okay. Any questions on that one? Okay. Keep moving. 3. You have 0.3 times 4 to the 0.2x equal to 0.2. Okay. So again, we're going to solve for x. So the first thing we're going to do is get rid of this 0.3 because we can't convert to log until we get rid of that 0.3 because we need the exponential function by itself. So we're going to divide by 0.3. And what we're left with is 4 to the 0.2x equal to 0.2 over 0.3. Or if you know your decimal trick, this just becomes 2/3. Because you can't have decimals in your denominator. So you move it over until you get a whole number. So if I move it over one space, I get 3. And however many spaces you move in the denominator, you'll move in the numerator. And this means I'll get the fraction of 2/3. Okay. So now we have the exponential function by itself. So let's convert from exponential to logarithm. And 4 is our base. So we are going to get log base 4 of the outside number of 2/3 equal to the exponent of 0.2x. There we go. And now we must solve for x. Okay. Let's go ahead, since we're going to be doing dividing by 0.2. Let me see. Well, one answer, if it'll let you, is log base 4 of 2/3 over 0.2 equal to x. So that's definitely an answer. But if it wanted you to convert it to decimal, then we could write it like this. You would first do change of base, and you would get log of 2/3 over log of 4 equal to 0.2x. And then I would calculate what that is. and I get log of 2/3 divide log of 4, and I'd get negative 0.292 equal to 0.2. And then I'd divide by 0.2, and we'd get negative 1.462 equals X. So that's if it's going to make you put a decimal answer. Let's hope it doesn't. Okay. All good? All right. We got it good. Okay. 4.
I have a question. I
What's
thought
up?
we couldn't have a negative for X within the log.
You can't take a negative. You can't plug a negative into a log, right? So I can't say the log of -1, but the output can definitely be negative.
Okay. Okay.
Got it?
Yes.
All right. Okay. No, good question. Yeah. So again, if it was the log of negative 1.462, this would not work. That would be an error or does not exist.
Okay. Sorry. Now that makes a lot more sense. Thank you.
Okay, for sure. Okay. Cool. Okay. And then we have 4/3 to the 1 minus x equals 5 to the x. So let's go ahead and rewrite this as a log. So here is our base, and we're going to get log base of 4/3, log base 4/3 of the outside number, and it's this whole thing, 5 to the x, set equal to 1 minus x. All right. So we have converted from exponential to log, and now we will solve for x, which means that this x is coming to the front. So we power rule that, and you get x times the log base 4/3 of 5 equal to 1 minus x. And now we're solving for x. So we're going to take this x and add it to the right side. And we get x times the log base 4/3 of 5 plus x equal to 1. Still solving for x. We're going to factor it out. And you get x times log base 4/3 of 5 plus 1 equal to 1. And we're going to divide by all of this nastiness. So our final answer is x equals 1 over log base 4/3 of 5 plus 1. Boom, boom, and boom. Yeehaw. Okay. Any questions on that?
Sounds like a no.
Right. Oy, this kid. Okay, cool. All right. You ready, Carl, or not yet?
No, I'm good.
You good?
Yeah.
You back?
Yeah. We'll see.
From having 3 twos?
Yeah.
All right, cool.
All right. Do you want to see me the link?
Oh, that's right. That's right.
I mean, I can do it on mine. You'll just, they won't have the
I just
notes on
had to
yours.
copy and paste it. All that good stuff. Where am I? Where am I? Bam. There you go.
All right. Share. Yes.
Cool.
Screen. All right. Okay. Is this the right one? Let's see.
The one above it.
The one above it.
Yeah. Loading. Look at all that fun stuff. My goodness.
All
There you
right.
go.
Cool. All right. So we have e to the x plus 3 is equal to pi to the x. We could try log base pi, but we already have log base e as the natural log, so let's do that instead. Of ln of the quantity e to the x plus 3 equal ln pi to the x, right? So this is going to work out to x plus 3 ln e will equal x ln pi. So ln e is log base e. Log base e of e is just 1. So we get x plus 3 equals x ln pi. I'm going to move my terms around so that I have like terms on both sides of the equation. X minus x ln pi will equal -3. All right. Now I want to get this x by itself. I have an x in both of these, so I'm going to factor out an x. Get 1 minus ln pi equals -3. Bring our work up here. X1 minus ln pi is -3. And then I will just divide this whole quantity over to the other side, and we get x will be equal to -3 divided by 1 minus ln of pi. And you're done. All right. Sort of the same thing with this one. We have 2 different numbers, 2 different bases. Now we could keep picking one base and running with it the way that Professor Carrillo has been doing it so far. But I kind of like to pick ln. And the reason why I pick ln will not be as valuable to you guys here, but as you get into higher mathematics, the natural number e has this very useful property that its derivative, you'll see this eventually, is just equal to itself. And then the derivative of ln x is just equal to 1 over x. So this makes this really easy to differentiate and to integrate. So in higher mathematics, differential equations, numerical analysis, all kinds of applied stuff, you work with e and ln whenever you can, because it just makes the math so much easier. So I'm going to do all of this with natural logs just so you can get used to seeing it. You definitely don't want to lose the ability to work with logs to bases other than e, but it definitely becomes very good to get used to doing everything with ln's. So we're going to take the natural log of both sides. We'll get ln of 5 to the x minus 2 power will be equal to ln of 3 to the 3x plus 2 power. By our power property, we'll get x2 ln 5 is equal to 3x plus 2 ln 3. All right. So same idea. We're going to, from the previous problem, I'm going to distribute everything around. So we will get x ln 5 minus 2 ln 5 will be equal to 3x ln 3 plus 2 ln 3. Collect my similar terms. We will get x ln 5 minus 3x ln 3 will equal 2 ln 3 plus 2 ln 5. All right. I want to factor out my x over here. Bring our work up. So we will get, if I just take this quantity right here and divide it to the other side, our final answer will be x is equal to 2 ln 3 plus 2 ln 5 divided by ln of 5 minus 3 ln of 3. All right, did I make any sign errors anywhere in there? I don't think I did. I did not. All right, cool. So any questions on this one? So this looks way nastier. I'm sure that like on paper, if you just picked one number over here, like if you made this base 5 or base 3, this end result would look less complicated on paper, but I can assure you that in higher mathematics, like if I had to take the derivative of this, or I had to integrate this quantity, right? Or I wanted to numerically approximate something to a high level of accuracy, this is going to be way better than using log-based something else. Okay. All right. What happened? All the stuff got deleted. Oh. He's writing notes on it. Okay. Let's see. All right. Okay, so this one looks like it's going to be another U sub, right? Because if we notice here, right, if I do 2x the whole thing squared, right, this is equal to 2 squared times, or 2 raised to the 2 times x, which is equal to 2 squared raised to the x, and this is 4 to the x, right? So this 2x right here, if you square it, you get 4x. So we're just going to do a U sub. I'll put this. Notice. Yeah. All right. So let's let U equal 2 to the x. Right. So then we'll get U squared minus U. Just kidding. Oop. Although you could do it this way. Minus U minus 12 equals 0. All right. So we have then, this will factor into U. What is this? This will be minus 4U plus 3. That'll give us minus 1U, negative 12 equals 0. So U will be equal to, oh, okay, there we go. Negative 3 or 4, one of these two. So let's go back to our, we're in the U world. Let's go back to the X world. So let's start with U equals negative 3. Then we have negative 3 equals 2 to the X. Nothing you can do with this, right? There's no number we can raise X to get this negative 3. That's not possible. So this one's straight out, down on that one. Let's do U equals 4. We get 4 equals 2 to the x. If you notice right away that 2 squared is 4, so you know x equals 2, that's fantastic. But if not, let's say 4 is equal to base 2 squared equals 2 to the x. And look at that. We can set our exponent equal to our exponent because they have the same basis, and we get x equals 2. This will probably work. If you want to check, you could plug it back in real quick. What is that? 16 minus 4 minus 12 is 0. There you go. All right. And let's do the next one. Okay, so this one's another U sub. I want a different color. Let's do purple. This is what I'm noticing here. Same process as above, right? But check this out. 4x, if I can write correctly. It's freezing up on me. Okay, there we go. 4 to the x plus 1 power, right? Now, if we remember, there's a rule that says this. X to the n times x to the m equals x to the n plus m, right? So this guy then has to be equal to, that's an arrow, not an equal sign, has to be equal to 4 to the x times 4 to the first, which is just 4 times 4x. So this is a U sub, right? Because this 4x squared would give us 16x, or 16 to the x. 4 to the x squared would give us 16 to the x. So let's let U equal 4 to the x. So then we get U squared plus 4 times U, right? Because this 4 to the x plus 1 is equal to 4 times 4 to the x. So U squared plus 4u minus 3 equals 0. Now let's factor this guy. This is going to be U. I can do this. Come on, catch up with me, brain. What's my answer here?
It doesn't.
It doesn't factor.
Complete the square.
Yep, gonna have to do a different one. You have to complete the square, or you could always use what do you call it? That gross, nasty
Quadratic
equation. Yeah.
Spamula.
All right. So let's complete our square, and we'll do it in place. So this will be U squared. This is plus 4u. Remember, my C term will be equal to b divided 2 squared, right? So in this case, if I take 4 divided by 2, that's 2. Square that, that's 4. Plus 4 minus 3 equals 0. So this is U squared plus 4u plus 4 minus 3 equals 0. So then we get U squared. Just kidding. We want this to be not squared. This factors down into U plus 2 squared minus 7 equals 0. Bring our work back up here. So this will be U plus 2 squared equals 7. Take the square root of both sides. We get U plus 2 equals plus or minus the square root of 7. And then we'll get U equals negative 2 plus or minus the square root of 7. Gross. Okay, let's go back to the X world. So our first one is U equals negative 2 plus the square root of 7. So then this is negative 2 plus square root 7 equals 4 to the x. Okay. Let's take log base 4 of both sides. I feel like something's going wrong. This should not be this complicated.
No, it's like this.
Oh, okay. 4 to the x. So then you will get log base 4 of negative 2 plus the square root of 7 equals x. I know this is bigger This is greater than 1, so we're good. Or it's definitely greater than 0. I should put it
Yeah.
like that. It's definitely greater than 0. So we're good on this one. So this will work. Whether or not it's actually a solution to this equation, we'll leave to a calculator. So then let's check the other one. U equals -2 minus the square root of 7. Well, I know just based off of the work I did for the first one that this right here, right, is going to go here. And this is strictly less than 0. So this cannot be a solution. So my only solution then, right, because you take negative and you subtract more from it, you get less than 0. So I guess I'll write it like this. Every time I try to erase something, it hangs up. There we go. I'll write it like this. U equals -2 minus the square root of 7. I don't even have to do any, like you could just say that this is less than 0. So it won't work. Sad face. Okay.
Nice.
And that's that. All
There
right.
you go. Cool, man.
Yeah. You want me to keep going?
If you want to, up to you.
Why not? Okay. All right. So this one, if you notice here, here's a problem, right? Take a look at this. What color do I want? Let's do orange. See this negative x right here? This is not a polynomial. So we cannot U substitute this the way that we would U substitute something else. So I think what I'm going to do is this. I have base 3 here and base 3 here. I'm going to take log base 3 of everything. And then this will be...
It would have to be of the whole left side, though.
It is the whole left side, yeah.
So it'd
Yeah,
be like it'd be like log base 3 of everything inside there, which
yeah,
would
that
make
can't work.
yeah. So
That
what you
can't
want to do is you can change 3 to the negative x into its fraction
Mm-hmm.
and get rid of the fraction.
14 times. Oh, it's 1 over 3 to the x.
Mm-hmm.
Let's see. 1 over 3 to the x equals 5. Yeah, that'll work. So you get 9 to the x squared. Right?
Nope.
No, just not. No.
So you're gonna multiply. So you want to get rid of the fraction.
Mhm.
So you're gonna multiply both sides by 3 to the x.
Yeah. Well, that's what I did. I just did the math wrong in my head. 3 to the x times 3 to the x equals 3 to the 2x
There you
equals
go.
9x. Okay, there we go. Don't
9
try to
to
do so
the
much.
9 to the x.
Yes.
But
That.
don't change it into 9 though. Leave it as 3 to the 2x. You'll see why.
Okay. It is more obvious, I guess, to make it as 3 to the 2x then. So this will be 3 to the 2x minus 14 equals 5.
To the 5 times
Oh, 3 to the
x.
2x.
3 to the x.
It is 3 to the x, ain't it? Okay. Now I see why it's easier.
Show the step, Carl. Just take that top one and just surround it in parentheses and
Oh.
multiply by 3 to the x. No. The one above it.
Yeah. Holy crap. Hold on. Let me start over. Showing steps is not for me, okay? It's
You
not
better
for me.
show steps. Don't give these students bad ideas. They already don't show enough steps. And I count points off for it.
Okay, well, just don't do math like me and you'll be fine. Which is not the point of why I'm supposed to be showing you how to do this the right way. For the love of God, just erase it, please.
It's probably taking its time. So just start at the top again. Oh, now it's just loading.
Yeah.
It's just loading now, huh?
Yeah, I just have to wait a second.
One day, 2 days later.
2 days. Let's just reload the page and see where we get to. Maybe that'll work.
Erases everything. No, it's good.
Uh-oh. It just
I have
locked
it
up
on-
me.
I have it on mine. If it's too slow, I'll jump in. Don't matter.
Yeah. Okay. You close this guy down. Here we go.
There you
All
go.
right. There we go. Let's see if it loads it in for me.
No, nothing's on mine, so you should be good to go. Because I think you erased everything there, right?
Well, this is popping up. It just took a second.
Oh, it did
there
too.
we go.
Okay,
Okay.
yeah.
All right. Well, let me show you the step. Let's see if I can erase this time. Maybe if I erase a little bit at a time. Okay. This seems to be working better. Okay, cool. All right, so we're going to take this whole thing that's really big and multiply it by 3 to the x. So then we'll get 3 to the x times 3 to the x minus 14 times 1 over 3 to the x times 3 to the x. And this will equal 5 times 3 to the x. All right. So like we already showed, this part here, do this on the side real quick. 3 to the x times 3 to the x equals 3 to the x plus x equals 3 to the 2x. All right, so 3 to the 2x minus 14. These will cancel. And this will equal 5 times 3 to the x. I'm going to subtract this 5 times 3 to the x over to the other side. We get 3 to the x minus 5 times 3 to the x minus 14 equals 0. All right, so now we have a u sub. So let's let u equal 3 to the x. So we get u squared minus 5u minus 14 equals 0. This will factor into u minus 7u plus 2. And this works because I know that the only factors of 14 are 7 and 2, and coincidentally, if I add one and subtract the other, I can get negative 5. Works perfectly. Okay, let's go to the u world, right? So we have u will equal either negative 2 or 7. That's a really bad curly brace. It's just a brace, not a curly brace. Okay, so let's start with u equals negative 2. All right. Automatically, this one should throw up a warning sign to you because this can't work. So let's check out u equals 7. 3 to the x. We'll take log base 3 of 7 will equal log base 3 of 3 to the x. So this is log base 3 of 7 equal x log 3 of 3. And this gives us that x equals log base 3 of 7. All right.
Yeehaw.
Holy crap. Okay.
You all right after that?
Yeah. Oh, man, I hate this one. Okay.
It's the same. It's the same as the one above.
I know, but I've gotten it wrong so many times. Okay. So this problem is like the bane of my existence from working in the math lab. I'm going to do it in pink. Okay. So multiply, we're going to start over here. E to the x minus e to the negative x divide 2 equals 2. I'm going to start by multiplying the 2 over to the other side. So we get e to the x minus e to the negative x equals 4. Multiply everything by e to the x. We will get e to the x times e to the x minus e to the negative x times e to the x equals 4. At this point, this is what I'm going to do.
E to the X.
Oh, yeah. times e to the x. All right. So just show you this step in two different colors, right? So e to the x times e to the x equals e to the x plus x equals e to the 2x. E to the negative x times e to the x equals e to the negative x plus x equals e to the 0 equals 1. Okay, that way you can see it in two different ways. Go back to pink. So this is e to the 2x minus 1 equals 4 times e to the x. Subtract this 4e to the x to the other side. E to the 2x minus 4e to the x minus 1 equals 0. Another U substitution. So let's U equal e to the x. So then this gives us u squared minus 4u minus 1 equals 0. All right. Have to complete the square on this guy. Gross. I'm going to move my work up here, though. Okay. So we get u squared minus 4u minus 1 equals 0. All right. So right here, we'll go plus and minus our c term, which is equal to our b divided 2 squared, right? So we get u squared minus 4, negative 4 divided by 2, negative 2 squared 4, plus 4, plus and minus, minus 4, negative 1 equals 0, minus 1, negative 1, minus 1, whatever. All right, so then we get u squared minus 4u, there's supposed to be u in there, plus 4 minus 1 equals 0. This factors to u minus 2 squared minus 5 equals 0. We get u minus 2 squared equals 5. U minus 2 equals plus or minus the square root of 5. And u equals 2 plus or minus the square root of 5. All right. Cool. Let's go back to the X world and get this out of the way.
Tell Jessica, bless you.
Oh, that's my roommate Schuler.
Oh, okay.
He doesn't deserve any blessings.
Well, he sounded like a girl sneezing. So there you go.
Fit u2 plus the square root of 5, right? So then we'll get 2 plus the square root of 5 equals e to the x, right? Yep. So we'll take the natural log of both sides. 2 plus square root 5 will equal just x. And we're done on that one. Now we'll go down here to u equals 2 minus the square root of 5. Now, just in case this isn't obvious, let me show you something here, right? If I have the square root of 5, right? Is the square root of 4, does it make sense that the square root of 4 is less than the square root of 5, right? And then if I solve this right here, I get 2 is less than the square root of 5. So I have 2 minus something bigger than it. This has to be less than 0. Does that all make sense? My dog is losing his mind.
Over the square root of 4.
Over
How
the
can the
square
square root of 4 be less than the square root of 5, Carl?
How?
I'm just kidding.
Oh, yeah. But anyway, hopefully that makes sense, right? And so, you know, you can always throw it in a calculator too, and you'll see that the square root of 5 is, what is this? It's 2.23, right? So you're subtracting something bigger from something smaller than it, it's going to be less than 0. So this one, right, we have 2 minus the square root of 5 cannot equal e to the x in any way. There's no way to make this work because this is a negative number. All right. Is that all of them? Okay. Hopefully I'm done making a
That's
fool of
it.
myself.
You're good.
Yeah. Anybody have any questions on any of that stuff? Anybody?
Give him a
You
thumbs
lost me.
up.
You lost me at square root of 4 less than square root of 5.
Okay. Well, if you want, I can explain that to you in a little bit more in depth, right? But yeah.
All right. Let me show you guys something before we take off. I did put some notes down when Carl worked the rest of the exponentials, is because I said in the beginning that there were two options. One, you can change from exponential to log, and two, you can apply logs to both sides and solve for x. Either way works, and both answers are equivalent. So down here, that's exactly what Carl chose. Carl chose to apply the natural log to both sides. You can apply the natural log or the log. It does not matter. But if you do have a base of e, it would be smart to apply the natural log to both sides, just because it's the natural number and the natural log, and they're inverses of each other. But as you see, there's Carl's work where he applied the log to both sides. And here's my work, which we were doing. And this one converts the exponential into an actual log. But you see our answers, they're a little bit off, but trust me, they are definitely equivalent. So either way works. It's just whatever you choose. Try to stick with one method, but it's definitely a good learning experience to know how to hash out both of them. Same with number 6. Carl applied the natural log to both sides. He got his answer of 2 natural log 3 plus 2 natural log 5 over natural log 5 minus 3 natural log 3. I converted in orange from exponential to logarithm, and I get a similar answer. Trust me, they're both equivalent, but again, it's different methods. These answers are the same, but they definitely look different. So this would be some good extra credit if you can show me how this answer and that answer are equivalent. That would be great if somebody could do that. I'll figure out the points if you do it too. But other than that, again, it's 2 methods. So you choose which one you like better. And then everything else, Carl, that was great. So if you guys have questions, please stick around. And again, before you take off, the student surveys are open. And I posted an announcement right when class started. If you take the student survey, or when you complete the student survey, go ahead and take a picture of the screen that says you have completed the student survey and upload it to your assignment. So I made an assignment called student survey upload or whatever. And when you upload it, in the comments, put that you want 5 points added to an exam of your choice. If you do not put that in the comments, you do not get the extra credit. So if you do the student survey, I will give you 5 points to any exam of your choice. And then upload that picture of it doesn't have to be the actual survey. It just has to be the message that says you have completed the survey. Take a picture of that, upload it, and in the comments say, I want 5 points added to this exam. And there you go. And that's it.
5 comments in the message we message you.